Hello dear students, today I will start new chapter, this last chapter, probability. Okay, so probability, just you have already studied from your previous class, from 11th class. What is probability? Just classical definition is what for any event, so finding the probability equal to what? Cases favorable to the event and total cases divided by total cases. That is our basic definition for finding probability of any event. Event means if we do some experiment, if in any experiment there are sample space, there is sample space having as a sample space can be treated as a set. The number of elements, the number of elementary events are contained in the sample space. That is total number of elementary events, that is the total cases. And for our event, for a particular event, how many favorable cases for in the sample space, that is how many elementary events or combination of events are favorable to the particular event. For finding the probability of that event is equals to what? The number of favorable cases to the event divided by total number of cases. That is the definition of probability. And we also you also studied about the addition property of probability. Probability of if two events are there, then the probability of either of this event or of this event, P A and B or P, just write A plus B, addition property of probability. Okay, so here the new topic is conditional probability. In the 12th class, we will start here conditional probability, first case, and second the multiplication theorem on independent events, and third is bias theorem. Okay, so in 3 stages we will study about this chapter, and remaining random variables, distributions, mean variance, and binomial distributions. This year these topics are removed from this chapter, so we will study only up to the required topic for this chapter. Okay, so first of all, conditional probability. What is conditional probability? Conditional probability, to understand conditional probability, just we can take an example. Suppose we throw 3 coins one by one or simultaneously we can throw coin. So that this is our experiment. Okay, so in this experiment, what will be the sample points? Because one by one throwing coins means 3 coins. Suppose first, second, third, 3 coins. First throw display something, second also, third also, the 3 positions are there. So for the experiment, throwing 3 coins. For the experiment, when we throw 3 coins, first maybe head. What is the sample space? Sample space. Okay. Sample space of random experiment of throwing 3 fair coins is what? Here, just in the probability, just thinking is main important, and you have to write in details for solving questions. So here I will write in very short for finding probability. So main thing is our thinking. What is the formula? What will be the formula? And what will be sample space, event, and how can we find what is the main thinking, basic conditional probability? Here, see, just 3 coin throwing 3 fair coins is sample space. Sample space contains how many points are there? First, the 3 places are there. First place may be head, so head, or tail. First throw. So first place may be head, may be tail. Clear? If first place head, then second coin may be head or tail, may be head or tail, may be head or tail. Here, for understanding, you can write, suppose like this, head, tail. With this, third position will be head or tail. With this, second position will be head or tail. And with this, head or tail. 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 Means, first position having H. Second position with head may be head or tail. And third position with this head may be head or tail. With this may be head or tail. Third position. This first position, second position, third position. So H. One position may be like this, H tail, H tail, H T H, H T T, 4. Clear? Now T H, THT, TTH, and last is TTT. This may be the position for outcome for throwing 3 coins simultaneously or one by one. 3 coins. 1, 2, 3, 4, 5, 6, 7, 8. 8 positions are there. Okay, for understanding what is conditional probability, just I will discuss in brief. So here, writing in brief and discussing just in detail here. Suppose now this sample space and each point of a sample space are called, what? Elementary events. For throwing 3 coins simultaneously or one by one, maybe 3 coins. We can get 3 heads or 2 heads or 1 tail and etc. So 3 head getting probability, total number of probability of event, probability of any event. What? Any upon ns. Ns means what? Total number of points in this sample space, the total number of elementary cases, then total number of cases. And any means total number of cases favorable to event E. So if event is triple H, means triple head getting, so 1 by 8, total number of here 8, 1 by 8. So Here, just we know this is a simple case. You have already studied about this. Now, suppose conditional probability, for there is a condition, there will be a condition. The condition means that one thing should be happen before finding the probability. There is one event already has occurred, and then we have to find probability for another event. Let E be an event. Suppose we are having two events, E and F. E event, at least two head appears. At event at least two head appears. Okay. And F be the event. First coin shows tails. First coin shows tails. Tail. There is a coin. There are head and tail in a coin. So if suppose this is an event, this is an event, E and F. Events, at least two head appears. At least two head appears. So we can collect two head appear from this event, because these are all the events. I mean, in the simplest case, so at least two head appears. What? At least means this is included, this is also included, and HT, H, and one thing more, THH. Two, 4 events. At least two head appears. And first coin shows tail. First coin, first position tail. So this nothing. 4. THS, THT, THH, THT, and TH, and TT. For understanding conditional probability, this good example. Okay, so just our first event is this, and second event is this. Suppose now this event, we have to find the probability of an event of getting at least two head. Whenever it is given that first coin shows a tail, it is given that before finding the probability, just we know that at the time of throwing coins, in the first throw, tail will come. Tail already has come. That is event F already occurred. And then we have to find at least probability of event at least getting two heads. But in this case, just we see that our target is what? Finding probability of event at least two head appears. At least two head. But we know that in the first throw, tail already came. Okay. So for getting favorable case for this event, just our thinking will be from this. First, okay, because we know first plus should be tail because already happened it is. So for finding favorable case to the event E, just we see from here because first position already failed by T. Clear? Here at least two head means two head only single position. Clear? So our favorable case will be what? 1. Only one this event. Okay, it can be get this favorable case 1. In this case, our thinking is goes to only for this set. That is, this is can be treated as a sample space for finding conditional probability. That is total number of cases will be 4 for finding conditional probability. So probability will be what? 1 upon 4. This will be conditional probability. Just I will explain it by taking set theory just like this. Suppose here we see that E intersection F, this two set intersection of these two. Only this element is common. Intersection of these two. What? T, H, H. Just we get intersection. This. Just I have discussed favorable case on a single point. So here intersection having single point. So this is favorable case may be treated. Okay. And total number of cases comes from for finding probability of conditional probability of this. Total number of from where? From this. Okay? From this. So F. Here NF equals to what? 4. And here NE intersection F is equals to what? 1. So 1 by 4 is probability. So we can write NE intersection F upon NE. This is probability of the event E. It is already known that or already it happened that the event F before finding probability. So what? Probability of E. Probability of what? E. Probability of the event E divided by F. Just we are denoting like this. Probability of E, F already happened. So PE by F equals to this. We can write. So this is our conditional probability. So we can define the conditional probability is what? Probability, conditional probability of E provided F already happened. Conditional probability means there are two events. One event is already happened. And for finding probability of other, PE by F equals to NE intersection F by NE. That means what? Number of elementary events. That are the events, elementary events. Number of elementary events or number of favorable cases to the event E intersection F. You can also, because elementary events, because just E intersection F contains what? Elementary events. Elementary events are what? Sample points. That is elements of the sample space. So these are the elementary events. These are the number of elementary events. So number of elementary events favorable to the E intersection F. Number of elementary events favorable to the event E. So conditional probability of E when F already has occurred is equals to number of elementary events favorable to the event E intersection F. We know any subset of this sample space is event, any subset. So number of elementary events favorable to the event E intersection F and number of elementary events favorable to the event E is known as conditional probability. So our conditional probability is defined by this formula. Okay. So here just now we will find some properties for this conditional probability. What is conditional probability? Conditional probability we have to find when one event already has occurred. Okay. So here just we will derive formula for finding conditional probability. Okay. So just we have seen that what P of E upon F is equals to what? NE intersection F upon NE. Okay, just we have discussed about it. Now here see, we know probability of this event will be what? Probability of probability of event A is equals to what? Na upon Ns. This is the definition of probability of A is equals to what? Na upon Ns. Means favorable case to event A upon total case. Ns means total case. So here just we can write it just like this. Ne intersection F, just divide it by Ns. Okay, just divide by Ns, numerator and denominator. So we can write like this, Ne upon Ns. So we can write this is what? Probability of event E intersection F. Probability of E intersection F upon N. And probability of, it will show what? Probability of E. Probability of E. So P E intersection E by F is equals to, this is conditional probability. This is conditional probability. P E by F. F already occurred. Probability of E. F already occurred. P E by F equals to P E intersection F by P E. Clear? So we can see here that P E, here also P E is in the denominator, so this should not be equals to, sorry, this is not F. This is F. F has already occurred. F. Here F. Okay, because its number of points in the F is treated as sample as for finding the conditional probability. So here NF. Just in the previous, if there is writing E, it is wrong. F. So N P E intersection F by P F. This is the conditional probability. So we can write now conditional probability like this. P A by B means what? P A intersection B upon P B. Suppose we are writing P B by A. So what? P B intersection A upon P A. This is by B, B already happened, here B. By A already happened, here A. And B intersection A or A intersection B, commutative, so both can be same thing. Okay, so here this is the formula, and also we know the formula what? A union B probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. This is addition. This is additional probability. So when just disjoint A and B are disjoint, then this is equals to 0. Disjoint means no common point is there. That is A intersection B equal to 5. Then just only you can write PA union B equals to PA plus PB. So this three formula we will use. This is for conditional probability. This is additional theorem. So just this formula can be used for solving the questions in exercise 13.1. Okay. Yeah, and also the basic idea of conditional probability. What is conditional probability? Just remember it. Okay. So this is conditional probability. Now here properties of this. Some properties are there also. Just like this. Suppose A is an event. A dash means it's complementary event. So just PA equals to PA dash equals to, we can write 1 minus PA. Means A not A, P not A equals to 1 minus P A. Similar to that, here we can write formula. So first property is probability of S by F equals to 1, and also PS by S, PF by F, PF by F equals to 1. Why? Just we can see that PS by F means what? PS intersection F upon PF. S means what? Sample space. So sample space and F intersection means sample space is the big set and F is subset of that. So S intersection F is equals to what? S intersection F equals to F. So PF upon PF. So what will be value? 1. Similarly, PF by F or A by A. How can we write? PA intersection A upon PA. We can write like this. A. So PA intersection A is what? PA upon PA equals to what? 1. So this is first property. Okay. Now second property. Second property is that just like this theorem. Just we can use this. A union B. Suppose probability of A union B by F. Probability of A union B. F already have occurred. Just you can write this. Divide by F. PA by F plus PA B by F minus P A intersection B by F. Use this. PA union by F by F by F by F. You can use this. Okay. So, and third property, just remember this. Conditional probability of A union B when F already occurred, just we have to find this. This means A, conditional probability of A by of B of A intersection B. If this A and B are disjoint, then this will be omit. Then this is equals to this, you can write for disjoint event. Third number, just P E dash by F is equals to 1 minus P E by F. Similar to that, P A dash equals to 1 minus P A. Just divide by A. Not divide, conditional probability. So just P A dash by F. P A by F. P E dash by F. P E by F. For this, just we know P S by F is equals to what? Since P S by F, S means sample space, F is a subset of that. So P S by F means what? P S S can be written as what? P E union E dash by F. Since E union E dash constitute S, simple as plus, because E complement of E, both if you combine, then you can get S. So S can be written as E union E dash. And by using this, since E and E dash are disjoint, E and E dash are disjoint, implies what? E intersection E dash equals to phi, disjoint. That's why in place of A and B, if we treat E and E dash, then this will be, probability of this will be 0. So we can use this formula in place of A and B, E and E dash you can use. This will be 0, this is the value. So P E dash by F plus P E by F plus E dash by F. Since E and E dash are disjoint, so we can apply this. And we know that this is equals to 1. P S by F equals to 1. This. So from here we can write P E dash by F. This is equals to 1 by this minus 1 minus P E by F. So this is our third. These are the property of conditional probability. Just we have to use this 1, 2, 3. These are the formula for solving questions from exercise 13.1. So very simple questions are there. Only we have to solve all the questions of the exercise, and you have to do also example. Example are also important. So here for solving questions, just we will write in very short, and you have to write in exam copy with detail. Okay. So just take questions from exercise 13.1. Okay. So one by one we have to find the probability, conditional probability, by using these formulas. Okay. The first question is, given that E and F are, just take question first. E and F events such that P, PF, PE intersection F or all are given. So just put the value and find the required answer. Here we have to find PE by F, PF by A. Okay. So just question first. Solution. First question, given what? PEPF. PE is P given, PF given, and PE intersection F given. Main things are given only. Okay. So we have to find PE by F. 0.6, 0.3, 0.2. 0.6, 0.3, 0.2. These are the given. Just we have to find what? PE by F and PF by E. So just use the formula. We know formula what? PE by E intersection A upon PF. This formula. Here PF intersection E upon PE. Here E is this happened, here F had already. F. Okay, E. Just put the value and you can get the answer. So E intersection F and F intersection E both are same. So you can write here 0.2 by 0.2 by f, this 0.3. So what? 2 by 3. Here 0.2 by 0.6. So here 2 by 6 equals to 1 by 3. So 2 by 3 and 1 by 3 are the answer. Just use the formula. And second question, PA by B, PB equal to 0.5. Question second, given what? P B equals to 0.5, PB equals to 0.5 and P A intersection B 0.32, P A intersection B 0.32. These are given value and we have to find PA by B. We have to find PA by B. This equals to what? P A intersection B upon PB. So just put the value and get the answer. 0.32 upon 0.5. 32 by 5. Not 32 by 5. 50. 32 by 50 means 16 by what? 25. 16 by 25. Okay. Just put the value for finding. So what are the given values? Just collect that value and just use the formula for finding the required probability PA by B. Yes. Question third, PAB. Question third, PAB and B by A is given. Just depend. How can we find the probability? Just depend. It's depend on the given value. Okay. Here we have to find the value of what? First, second, third. A intersection B, B A by B, and PA union B. These are values. Just question third. Given values are what? PA. Given values PA, PB 0.8, 0.5. 0.8, PB 0.5, PA, B by A equals to 0.4. B by A equals to 0.4. Here conditional probability is given. And for we have to find first PA intersection B. PA intersection B. First is we have to find this. Second we have to find what? PA by B. PA by B. And third, we have to find what? PA union B. PA union B. Just this. Here we see that PA intersection B is involved in the conditional probability theorem. Okay, for finding this, since this B by A is given, so this is equals to what? PB intersection A upon PA, and this is equal to PB intersection A and A intersection B. Both are same PA, so this is equals to what? Here PA B by A is given 0.4, and PA is given also 0.8. Here 0.8. So we can find, just multiply 32 is equals to what? PA intersection B. So PA intersection B equals to, we get what? PA intersection B equals to, A intersection B equals to what? 0.32. So this is 0.32. First answer. Okay, 0.32. Now for finding PA by B, it can be find P, just formula what? PA intersection B by PB. So here PA intersection B already find 0.32. 0.32 upon PB. PB equal to 0.5. So 0.5. So this is equals to what? 0.5 means 0.64. 0.64 we can write. Okay, 0.64 because 1 by 2 times 0.64. Now third number questions, pay A union B we required. So we know PA union B equals to, we can write PA plus PB minus PA intersection B. We know this formula. We know all the formula. Just we know this, and for that first this is, and here just we have to find A, PA union B. So these three things are known. This is PA, PB and PA intersection B. So equals to what? 0.85, 0.8 plus 0.5 plus minus 0.32. 1.3 minus 0.32, that is what? 0.98. 0.5, 0.5, 1 minus 32, 0.5, 0.5 and 0.8, 0.8, 1.32, 0, 0.32. So 0.98, 0.98, 0.98. This is the probability. So just use the formula. Okay. This formula is a traditional probability. Okay, now question 4. 4 can also be found. Evaluate PA union B. Just find this PA union B in the question 4. Okay, here given what? P. Just in combined relation. The given values are in the combined relation. Okay. So just we have to find PA union B. So take one by one these questions. Question 4. Question 4. What is given? Just we have to find PA union B. PA union B. We have to find PA union B. Here given is 2PA equals to PB equals to 5 by 13. Given 2PA equals to PB equals to 5 by 13. It is given. And PA by B 2 by 5. And PA by B 2 by 5. These two things are given and we have to find PA union B. That PA union B means PA plus PB minus PA intersection B. So we require PA PB and PA intersection B. A intersection B can be found from here. So in this relation, this equal to this equal to this, then PB equal to this, PA equals to this is equals to this means what? PA equals to this means to go to here 5 upon 26 and B equals to just see here 5 by 13. So PA PB are no also given this since PA by B is equals to what? 2 by 5 and we know PA by B by conditional probability PA intersection B upon PB equals to what? 2 by 5. So here PA intersection B is equals to PB into this. So 2 by 5 into PB and 2 by 5 into PB. PB means what? This 5 by 13. 5 by 13. So 2 by 13. So PA intersection B is 2 by 13. We know that PA union B equals to what? PA plus PB plus minus PA intersection B. So just our target is A union B finding. So PA PB and PA intersection B. Three things are known. So just write here. 5 by 30 is 26 plus 5 by 13 minus 2 by 30. 2 by 30. So you can solve it. 1 by 13, 5 by 2 plus 5 minus 2. So it 3, 6, 11 by 2, 11 by 26. So value is 11 by 26. Okay, so this is the answer. So just you have to find like this. First of all, it is given, so we can get this value and this value, and then use this here. Just use formula and you can get PA intersection B. So three values are given. This. So here use this formula and you can get the value PA union B. Okay, this is question 4. 5 PA PB PA union B is given, then you can find all the values. 5 is similar questions. So you have to solve here. What is given? PA is given, PB is given, and PA union B is given. Three things are given. PA given, PB given, A union B is given. Okay, so first of all we require for finding conditional probability what? PA intersection B. So find by using this formula, and then PA by B, PB by A you can find just using the conditional probability formula. Okay, so 6, question 6. Next question is 6. Here the given data determine PE by F from question 6 to 9. 6, 7, 8, 9. 4 questions are given for finding PE by F. PE by F. So just here different type of events are given. Okay. Different type of events are given. Just you have to write as a set theoretical point. Okay, first question 6, just we have to find what? P E by F. We have to find P E by F equals to P E by F equals to, for all the questions 6 to 9 questions. So here given what is event E and what is event F. Just you have to write as a set theoretical notation. First of all write sample space, then E, then F, then just find this value. If you can write E, then E and F, then you can find E intersection F and NE, and the probability of that 3 E, F and E intersection F can be found by using parabolic case upon total case, and use this formula for finding this in each questions. Here questions 6, 7, 8 are same type of questions. Okay, so first 6, what is given? First what will be the value of E? Here sample is, first of all a coin is tossed 3 times. A coin is tossed 3 times. Where? Event. 3 times, that is sample space will be what? Just you see in the previous question. Head, 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 tail, and then head, tail, head, head, tail, head, and then head, tail, tail, head, tail, tail. This also tail, head, head, tail, head, tail, head, tail, 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 head, tail, tail, tail. Sample space for the question 6. sample space. Is in question 6. A coin is tossed 3 times. So sample space is this. Just events are defined. E head on third toss. E head on third toss. Third toss means third position. In the third position, head. This, 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 this. So you can write H, 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 T, H, T, H, H, T, T, H. This is E. And F, head on first 2 toss. Head on first 2 toss. Head on first 2 toss. This, only 2. This 2 and this 2. Head, head and head, head, tail. Okay? This. Just as defined, you have to write. And implies E intersection F. Just take intersection of these two. Because we have to find this, and this is equals to what? P E intersection F upon P F. We recur this to probability. So P E intersection F is required. P E intersection is F is equals to what? Intersection of this. So this and this. Only this is common. Only this is common. So H, H, H. Therefore, we can find what required? Probability of E intersection F is equals to what? N E intersection F upon N S. N E intersection F. E intersection of how many elements? 1. So 1 upon 8. There 8 elements are there. So this is P E intersection F. So P E intersection F is equals to this. And P F, because we require P F, so P F equals to NF, NF upon NS, 2 upon 8 equals to 1 upon 4. 8 total number of case, and F 1 to 2 to 1 by 4. So this is equals to what? P E by F 1 by 8 upon 1 by 4. So 1 by 2. Probability E by F equals to 1 by 2. Okay. So as a similar case, just you can find the probability of all the given, for all the given conditions. Just write the sample space, just write E and F for all different questions. 6, 1, 2, 3, 4, E and F, then intersection, then find this probability and then put value and you can get the P E by F. Okay, so do it from yourself. Yes, 6, 7. 7 can also 2 coins are tossed on 7 can also solve 2 coins are tossed. So 2 coins are tossed, then you can write the sample space. How? 2 coin. Seven. 2 coin means H, H and HT and TH and TT. This will be the sample space for 7. Okay. And just prepare, write the E and F, then finding value. After finding value, and you can get write E, write F, F and E intersection F, and find probability and put the value, and you can get. Okay, question 7 here. 8. A die is thrown 3 times. A die is thrown 3 times. 8. A die is thrown 3 times. Okay. 7 you can do. Just complete 6, 7. The same type of questions. Here die. Here die thrown 3 times. A die is thrown 3 times. Question 8. Sample space is contain 6 into 6 into 6 equals to 216 elements. Sample space will contain 6 into 6 into 6 216 elements. Because 3 die throwing. First times getting suppose 1, and with this another 6, and with that another 6. 6 into 6 into 6 216. Okay, and here events. 4 appears on the third toss. 4 appear on the third toss. What event? E. Therefore, NS equals to 216. Event E. Event E will contain all the elements. Which element? 4. But third toss 4 appears. Means there are 3 positions. First toss, first throwing, second throwing, and a die is throwing 3 times. Third throwing. So 1, 2, 3 position are there. So first, fourth position will be, third position will be 4 in all the cases. Okay. So we can write first 1, then second 1, 2, 3, 4, 5, 6. 1, 1, 6, 4, and then what? 1, 2, 4, and then what? 1, 6, 4. Just like this. First 2, 1, 4, and so on. What? 2, 6, 4. 2, 6, 4. You can write like this. Here 6, 1, 4, out 6, 6, 4. This type of element will be there. So how many elements will be there? This is fixed. So 6 into 6. How many elements will be in F? Just 1 and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Whereas 2, 1, 4, 1, 4, 1, 4, 2, 4, 2, 4, 2, 4, 6 is 36. So E have this element, and F. F is what? 6 and 5 appears respectively on the first 2 throwing. On the first 2 throwing. So F will be what? First and second will 6, 5. Okay. So 6, 5 and 1, 6, 5, 2, and so on. 6, 5, 6. 6 element. So 6, 5 is fixed, and 1, 2, 3, 4, 5 up to 6. So these are the elements. Now we have to find P E by F. So here E and F implies E intersection F equals to what? E intersection F. Here 1 point will be 4. Here 1 point will be what? This, 6, 5, 4. Out of 6. 2, 3, 4, 5, 6. Just you can write in detail. 6, 5, 3, 6, 5, 4, 6, 5, 5, 6, 5, 6. So this is element is common to this because their third position is 4. So single element. Single element. What? Intersection element is 6, 5, 4. Single element. The intersection. And F will contain 6 element. Therefore, here P E intersection F equals to what? Probability 1 upon what? 216. And PF is required. What? PF? PF means 6 by 216 equals to 1 by 36. Okay. Sorry. This. Thus, PAE by F equals to what? PE intersection F upon PF. Just you can find the value. Put this value. Okay. What? 1 by 1 to 216 upon 1. 6 by 216 equals to 1 by 6. 1 by 6 is the answer. 1 by 6 is the answer. Clear? So just write sample space. How many elements are there? Event E, event F, taking intersection, then find two probability according to definition. Just put the value, you can get the answer PE by F. This question 8. Now question 9. Just same type of questions here also. We have to find PE by F here. Mother, father and son line up at random for a family photos. Okay. So just you can solve it, I think, because so mother M and then father F and son S, then you can write sample space. What sample space will be? For question 9. Okay. If M mother, F father, S son, then sample space is as follows. Sample space will contains what? The 3 elements are there. Okay. So what? How can we arrange these 6 elements in 6? 3 elements M, S, F. So we can write like just like this: M, F, S, and M, S, F, and F, S, M, and okay, here sample space is big. Sample space, just sample space, because for notation there is the S for son. Okay, so M, F, S, M, S, F, F, S, M, F, M, S, and S, F, M, and S, M, F. 1, 2, 3, 4, 5, 6. 6 position are there. Okay. Total elementary events 6. Now here E, sun on one end. Sun on one end. That means E is sun. Any of the end, here or here. So here and here, here. Three elements are there. Okay, son. Either of the side. No, 3, 4. 1, 2, 3, 4. So M, Fs, and this FMS, and also SFM and SMF. Because sun may be either on end. This side, or this side. Okay? And F, just F also write. F is further in middle. F, this 2. MFS and SFM. Just take that. Now we have to find the P here. From here, just we can find P intersection F equals to what? Just see. Intersection MFS, SFM. This is the intersection. Okay. So intersection is also same. MFS and SFM. Therefore, E intersection F is equals to what? 1, 2. 2 elements are there. So 2 by 6. Total is 6 equals to 1 by 3. And PF is also required. So F means what? This 1, 2, 2. 2 by F. 2 by 6. 1 by 3. So probability will be what? This by this 1. Thus, P E by F. E intersection F upon PF. 1 by 6 upon 1 by 6 equals to 1 is probability of question 9. Okay. So these are the solutions of up to question 9. Question 10. So you can solve just as a similar formula is used for remaining questions. Just try to solve and solve all the examples also. Okay, and write in your homework copy and send me solutions of at least 3 questions as a PDF file for your attendance. Okay, just I will continue on the next class. Okay.